So below grade work. Think of the house as a shoebox. I'm going to work from the basement up, and so this was some detail we provided. When we put these bid packages together, I tried to provide the contractor that was going to bid on it with as much detail as I possibly could. Because first of all, I wanted every contractor to be getting the same amount of information. We held an open house where we had all these houses were available for the contractor to come and look at. Because taking good measurements is important. Estimating the amount of material you're going to use, and going from there. So we provided them with detail. And we encouraged suggested modifications. That was the nice thing about having a building science team in the background, because anything that was we did solve some problems throughout the process. We didn't have every best answer. The builders would propose solutions, and we'd model it and look it over from a building science perspective, and then get back to them whether, okay, that's a good solution, let's try that. So basically what we're doing here is we're going to insulate the interior walls, we're going to insulate the floor, and we're going to provide drainage, a drainage plane. Just a mock-up. I used, this is a Google product. It's free download. It's called SketchUp. Nice, because basically we built the wall sections. We could rotate them. We could put anything on them we wanted. So when we showed this to the contractors, they really got it. And all those little asterisks numbered, I had a specification sheet that called out what I wanted them to use for that material. And then we had some vendors, we had some manufacturers, distribution, local distributors. We tried to buy everything local in Utica, provide the material.
What's the pink triangular?
That's basically spray foam with a rim joist. I mean, it didn't have the bubble. It didn't have the bubble picture. So, yeah, but I'll talk about that. Yep. No, that last piece of blue, and I'll show you some detail, we left that up off the floor 4 inches. So, and that material on the bottom, that tan stuff, that's a dimple mat, inverted. So it's kind of like they use it in astroturfing. It allowed a channel for the water, if ever, to run down the wall and then drain towards the sump area. And then we insulated above it. This is some of the detail. You'll see there we left it off the floor 4 inches. And that house had a French drain, channel drain. I think that's what you call it, French drain. Is that right? French drain? Channel drain. Sometimes those were compromised. We had to deal with that. Putting insulation to an existing basement wall, that can be quite a challenge. I mean, you don't have perfectly square walls. They aren't all perfectly jointed concrete. I mean, so we had a lot of challenges. Sometimes we had to move sewage pipes. We had to move electrical panels, gas meters, things like that. But it's all possible. And it was great to see the builders, the building contractors, taking this on, not being overwhelmed by it.
Was it cheaper than spray foam to go with the
Yeah.
panels even after release?
Yep. And there's an issue with spray foam, and I'll tell you that in a minute. Basically, this was like before and after. That's the exterior finish in the basement. That is Thermax, Dow Thermax product. It meets the ASTM 84 smoke and fire rating spread, flame spread and smoke spread. So up to 4.5 inches, you can leave it exposed. So we didn't have to cover it. If we spray foam, we either have to dope the spray foam, which compromises the R value, or put something over it. And most of these basements, one of our checklist criteria is nobody was living in the basement. We wanted to create a space where it'd be comfortable for them to, do laundry and stuff. But if the basement had living conditions, we didn't take the house, because the floor treatment that we did, the top layer is like a Durarock. It's a softer, it's like tile board that they use in a bathroom. So you can walk on it. It's fairly okay, but you wouldn't want to be down there, jamming with shoes on all the time and putting bedposts against it and all. Affixing the rigid, I mean, it's a lot of labor. Those screws are like 6 inches long, pre-drilled, stainless, washer on them. I mean, it's work. Just some detail at the stairway. We were trying to avoid like spray foam as much as possible. Spray foam, it's a great invention. It's out there. It's used a lot. Solves a lot of problems, but it also covers up a lot of problems too. Sometimes people can go just crazy with their wand, and so we tried to. And the other reason we liked the sheet stock material, it allowed the contractor to be kind of self-sufficient. He could go to the material store, get sheet stock. He didn't have to hire, like, there wasn't a team of like 15 different contractors in the house at the time, because that's where a lot of logistics and organization and communication break down. Because the one guy's like got his little thing, and the other guy's got his little thing, and they don't communicate, and next thing you know, the homeowner's got a mess. And they both want to get paid more than they bid, and you know, it just, you guys know the story. So we tried to avoid that. What was that? I got one of those. Yep. Yep. This is basically top view looking down at what the wall is treated with, basement wall. That first layer of rigid, that's XPS. Margot talked about that earlier. That's grooved. It's called Paramate. I mean, you could, if you were doing this project on your own, it'd be nothing to take a dado blade on a table saw and groove your 2 feet wide sheets of XPS. We didn't want to have, you know, to pay for that labor for the contractor to have to deal with. So we specified Paramate. Paramate comes with a groove in it. You got to remember to put it on the right side, though. I've seen Paramate put to the exterior wall facing out. So basically, all it does is fill up with dirt, and it never channels the moisture. The idea of that groove is if there's any hydraulic bonding moisture that's coming out of the foundation, it gets in that groove and drains.
Are you taping any of those seams?
We taped the lath layer. We didn't tape the XPS. Oh, I must have went up. There's the Paramate. About the same cost as the 2x8 rigid tongue and groove. It was kind of nice because calling up in advance, once I built the bid package, I designed the specs, had the building science team weigh in, we kind of got that all resolved. I started calling supply places in the Utica area to see if they had this stuff. Because I knew my first call once I sent the bids out was, Greg, where the hell do we get this stuff? I wanted to avoid that, so we basically screened a few places, and some of these people, if they'd at least heard of it, that was a good sign, and then a lot of them ordered it in. And again, this gets back to volume, because think of how the solar industry has been able to drive its costs down. A solar installer now does 5 panels, like maybe, or 5 jobs in a 2-month period. The panels come in, he's got a crew, they're used to getting up on roofs, things and that. It's a volume discount. I wanted to create that with this pilot. Unfortunately, I couldn't with 4 houses, but we were able to establish the supply chain that could be created to get the materials.
Greg,
Yes?
you did the outside of the building. Is that included in the basement?
No, all the basement stuff we treated from the interior. We had to, because otherwise we're digging outside the gas lines, pipelines, the neighbors' wire or whatever. I mean, it's just a nightmare. Rubble foundation. This was actually solved by a contractor. They ran into this at one of the houses. You know, Greg, we got rocks and we got mortar, but we don't know where the mortar is, because the mortar is where the pilot hole will go and would actually accept the stainless screws. So they said to me, you know, how about we fur it out? Advent Tech, they put it horizontally. Yes, it compromises a little bit of the drainage, but this was a fairly dry basement anyway. So this gave them an application surface. So when they put the Paramate up against that, solved that problem. Yeah, Advent Tech, flooring surface. No pressure treated. Yeah, composite, Advent Tech. Band joists, what we found, or what we took it to later. Basically, you got to be careful spraying foam against studs that have evidence of moisture. I mean, that was part of our checklist. If there was any moisture issues in there, we would have treated that a little bit differently. We would have created an air pocket and a way for it to breathe and drain. But these band joists and floor joists were in decent shape, so we apply the foam right against it. So that creates, basically that's the junction point of the 1/3 of the shoebox. Basically, we're out of the ground, we're up to where the sill plate meets for the exterior walls. So that's our bottom third of our envelope now is defined. Basements, obviously, we had a checklist. We didn't want like rivers running in the basement, but obviously we couldn't walk away from every house that had any issues with moisture. So this house, we actually channeled a drain into it, put down piping, stone, backfilled it, and then drained that to a sump, a dry sump.
Everybody in the back see that?
Yeah, was the light...
We can turn the lights down if we need to.
Basically, the picture on the right is stone above it, of a decent size, small, so it doesn't impregnate. And again, these basements were minimum utilized. I mean, mostly laundry, the mechanical systems. They weren't like down there daily living.
Did you encounter dirt floors?
Yeah, portion of dirt floor. So with that, we used EPDM, the stuff Margot talked about earlier. We laid that as the initial layer, and then came with our strategy.
Jackhammered that thing?
Yeah, a lot of fun. College, summer job people, I think. Most of this work was done in the summer. It was great to see them solving problems. I mean, when I went out to these job sites, it was just, they were thrilled to be doing this type of work, because mostly what they do is go insulate houses with spray foam and air seal and, do BPI type stuff. So this was it was an opportunity for them to bridge the next level. This was what the finished basement floor started to look like, and we had some issues. So I'm going to, it's good to have issues because then you solve problems. Basically, there's the dimple mat impregnated, the XPS over it, and then we're coming along with the Durarock, which is up on top. So like I said, you're not down there playing basketball or walking around with high-heeled shoes, but it provided a reasonable surface, and it was insulated. Oh, yeah. Yep.
Greg, isn't the heat loss from the cellar floor pretty small?
It's small, and we're actually going to have data this year that we'll be able to quantify that, because one of these floors, we had to rip it out because the basement flooded with sewage, and I'll show you why. And when that happened, it just compromised. The good thing is those two first materials are inorganic, so there was no bacteria, no mold created, but it was just such a risk of it being, infected or whatever. We hosed it out as best we cleaned it. Finally, we just made the call, we're taking the floor out. And I work with Terry Brennan some. I don't know maybe if any of you know his name. He's a building scientist out of Utica area. He's thrilled because we're going to have some data. We're going to have a winter. We had a season of energy data before with the conditions of what we did to it. Now this winter we'll have it without. So it is fairly small. If you think of that shoebox, about maybe 10 to 15% of the pressure is happening in the bottom third. Maybe about 25-30% is at the walls. The rest is the roof in the attic. That's why also in deep retrofit, if you get to pick one solution that you can afford to start and then think about the others, go for the roof first. That's the finished floor, so it wasn't bad. It tightened up pretty good. This was what happened. This is what we learned about in Utica. And this is not uncommon in most cities, probably in the Northeast. It's illegal to do this anymore, but a lot of cities, the stormwater runoff shares the drainage with the city sewage. And what happened was in April, before Irene or any of that, we had a lot of water. And one of the houses got backflow into the house. It happened to be the house where we were data logging. So we had a bunch of Campbell scientific data loggers on the floor, and the homeowner sent me a nice picture of those floating in 6 inches of sewage. But the enclosure we put the Campbell data loggers in held up, so we kept collecting data throughout the process. But what happens is The storm runoff exacerbates the village sewage line, and one of them's got to win. So the lines that are trying to discharge down to the water treatment plant become backed up, and then all of the water heads back for the houses. So what we did here was we installed a check valve at the exterior outside the house, about a $2,500 job. It required a plumbing permit. We had to get this Mohawk Valley Water Authority involved. But we installed a check valve that basically senses when there's backflow coming back from it. This only lets water go out. And they can manually operate it like in a storm to make sure that everything's good shape. So we had a good before and after because we had the flood, we had the problem, we took care of the floor. Now that floor was worth salvaging because this actually happened to 2 houses, 2 of the 4. So we fixed that floor because that floor was worth salvaging. We installed this strategy, and then when Irene occurred, this was like Taylor Ave in Utica. It's a sloped street that comes down from like a cemetery area. They were the only house on the street that didn't flood. So we had a good before and after case. So it's just another, like if you're making a checklist, I mean, this is now on the checklist. It's to be aware. Are the storm and sewage drains shared? And any town that's upgraded or done new additions, kind of like what we talked about earlier with what triggers a building permit, cities have had to do this also. But again, it's not done everywhere yet. This was another problem in that same basement. The plugs, the lights down a little on this would help. The plugs in that sump on the left-hand side are friction fit. Oh, it might affect the guy filming. Well, maybe not. Okay, there we go. They're friction fit. So basically, when that pressure back through there, and again, there's 2 houses, so it's two sewage drains. Those things blew out of there like wine corks. A building code official probably would have caught that in an inspection, I would hope. We didn't catch it when we were doing the basement. We didn't notice that was a problem. So on the right-hand side, that's threaded, fit, compression, pressure tight plugs, so they shouldn't have that problem next time. You can put the lights back up, somewhat. Is it either all or nothing with those? Or? Okay. Oh yeah, we put check valves in both houses. We replaced the floor in one, because the other one, it was too compromised. This is what I was talking about a little bit earlier, structural beams. If a structural beam is let into a foundation wall, you got to be a little careful there with how you're going to insulate around there. It's just things to be aware of. Wood and masonry, we probably have a lot of that in the north, in our housing stock. Interior insulation, basically you want to let wood dry. This is one reason I like exterior insulation, but again, it's not always the solution. Because if you get the guy in there with a wand and he's spraying away, I mean, he can actually cause you some future problems. And your mason walls are cold, so they actually they promote that dew point that I showed earlier. How are we doing for time? Oh, great. We'll take a break at some point. So this is a beam let into the concrete wall. Again, it was a dry beam, not a lot of dry rot. So we did a little bit of detail behind that, but we basically foamed it. And that was their main carrying beam, so we only had one of them to deal with. But it's just more things to be aware of. Okay, so we're done with 1/3 of the shoebox. Now we're going up to where like 30% of the leakage and effect can occur. Again, we provided them with detail. This is the part on the left is where we're coming out of the basement. We've made that pink triangle is that detail you just saw earlier, the rim joist. And now we're going to the exterior. We're going to hang 4 inches of rigid insulation and an air barrier to the exterior of the house. So we're not going to put that against the siding because the majority of siding is vinyl, and that might have 3 screws per 8-foot sheet. So we're not going to trust that, you know, we're just going to that exterior siding. I mentioned earlier, there are several strategies how to skin this cat. If your house has siding and it has lead and you don't want to deal with it, there are methods to build the wall out over the siding. You don't have to go down to the sheathing. And I can share that detail with you in the future if you're interested. But in our case, we wanted to go down to the sheathing. All of the houses were vinyl sided from the exterior, the first layer anyway. And we wanted to guarantee, because you'll remember I had that air tightness bogey, pretty aggressive, 0.5 per shell square foot. So that meant they wanted to see what they were going to start sealing from the exterior. So we went down to the wall sheathing. Yep. The red is actually, yes, the board. Yep. We put an air barrier over it, thermoply. The backer rod is the, that was kind of a neat detail, and I've got a good picture of that. That's basically where our wall assembly met. We overlapped the basement wall on the exposed part of the basement wall. So we had a good, if I drew a thermal convection arrow there, you would hope that it would go from the pink out to the pink. I mean, basically, we're not going to lose much through that exterior wall cement there. And then we strapped it for insects and bugs and rodents. 2 layers, staggered and lapped. You'll see. It's pretty interesting. You can get it. It's like people use it for, think of, you know those kids when they go in a swimming pool and they got the little thing and they turn it into a hoop? It's that material. It's squishy. Yeah, earplugs, yep. And then strapping, because we had put siding back on the houses, and wall detail. And then this is where the wall meets the roof cavity. We had strategies here. If we were, like in this example, this is where we are going to a new roof. So basically, when we came with our last layer of rigid insulation, we just married it into the thermal barrier that we were putting on the roof deck. Because with the roof, it was the same strategy. We went right down to the sheathing. So this was the 2-family house after we started to strip. We took, I think there were 3 layers of siding on that house off. And we did say we salvaged the vinyl siding. So when we put the house back together, we were able to utilize the vinyl siding that was recovered. We obviously needed some more because we made the house fatter, but we were able to get 2 sides of the house covered with the vinyl siding that we took off of it. That basement wall, I'm just mainly showing that for detail because that's where we're gonna meet our exterior wall with.